everybody. My name is Victoria Haberbush, and I am the Senior Director of Commercial Product Development at Aspira Women's Health.
And I'm Todd Pappas, Vice President of Research and Development at Aspira Women's Health.
We're here today to discuss some exciting news. On March 15th, our poster entitled A Protein Biomarker Test and Artificial Intelligence-Based Algorithm for Ovarian Endometriosis was presented at the Society for Reproductive Investigation in Vancouver, British Columbia. This work showcases our recent advancements in utilizing protein biomarkers to detect certain forms of endometriosis and represents a huge step forward in the field. From our previous work with ovarian cancer, we saw a correlation between some biomarkers and endometriosis. We utilized AI to develop an algorithm and trained it on our internal data set composed of women with adnexal masses, where this algorithm had very high performance. We then applied the algorithm to an external data set that included both patients with and without adnexal masses. In this cohort, we found that the signature had superior performance in the presence of masses, also known as endometriomas, and was less sensitized for deep infiltrating and superficial forms of the disease. Upon investigation, we realized the biomarkers performed extremely well when the endometriosis had some form of ovarian involvement. So Todd, how did AI assist you with developing these algorithms?
We used machine learning, a type of AI, primarily to assist us in identifying the most relevant biomarkers and the best method of combining them, with the eventual goal of classifying patients with endometriosis based on these biomarkers. So both in the development of the initial algorithm and the subsequent algorithm we used to investigate ovarian involvement hypothesis, AI enabled us to find critical biomarkers and understand their possible contribution to the classification.
So what was the driver for you and your team to investigate this issue?
Diagnosis of endometriosis is a significant unaddressed medical need. Many women experience significant delays in their journey to obtain this diagnosis, and currently the only way to diagnose endometriosis is via laparoscopy. We're investigating biomarkers as a non-invasive method to detect the disease.
So how did you go about performing this study?
As you stated, the initial serum biomarker algorithm performed well on a cohort of women with masses, but in a mixed cohort, it showed greater sensitivity for endometriosis with ovarian involvement. We investigated why this might be. The ENDOX data from our colleagues at Oxford, which was this mixed cohort, was extraordinarily well stratified in terms of the endometriosis type. That is, like, was it ovarian endometriosis, endometrioma, peritoneal, or deep infiltrating? Evaluating the performance across these types revealed that the algorithm performed extremely well in the cases of endometrioma, pointing to the hypothesis that a key driver of the algorithm performance might be the tissue that was involved in endometriosis. To support this hypothesis, we developed a subsequent machine learning algorithm based on the ENDOX set. This model showed good performance for classifying both endometrioma and superficial ovarian endometriosis that had yet to become endometrioma, suggesting some common feature between these.
So what are the key takeaways from this study?
While previous studies have questioned the role of biomarkers as non-invasive tools for endometriosis, these data show that biomarkers can perform well depending on the tissue involved and perhaps reacting to the endometriosis. This is a significant achievement by any measure as we move towards a non-invasive tool for endometriosis.
So what are your next steps in terms of these data?
Well, the next step in any study, of course, is further study, and that is studies to evaluate these hypotheses using independent data sets. Additionally, we've been exploring other biomarkers that may allow us to identify the disease more broadly. Victoria, you were the one who presented these data in Vancouver. What was the reception?
The reception was extraordinarily positive. I had numerous great conversations with experts in the field. There was a huge amount of excitement around these data. Specifically, they provide some insight into why and how protein biomarker performance has varied for endometriosis. The ovarian involvement hypothesis was also very well received, especially by those familiar with the disease's pathology.
This work is a great first step toward the development of a non-invasive test for endometriosis. Our data point to the possible tissue effects. In other words, these protein biomarkers could be indicative of the tissue that is reacting to the endometriosis. This is something to keep in mind as we develop further non-invasive diagnostic tools.
Well, we're extremely excited to see what your team does next. Thank you all for watching, and we'll see you soon.